IBM since 2008. So I have been with research, and I have background in data mining, HCI, and web mining kind of research. I joined IBM after my PhD from Stony Brook University in 2008. Now I'm like doing research on social media analytics, data mining. Also manages a small team that responsible for doing text analytics research for IBM's personality insights, tone, and emotion service. That is like part of IBM Watson Innovation. So that is about the introduction. I will talk about tone analyzer, tell you more details about what we do to develop this service, and we'll show you some use cases and show you some demo, and I'm happy to answer any questions. And the best part of this will be to establish the connection, and we can keep connected. And as we always communicate that IBM is now pretty open on we are deploying services on Bluemix. We are like inviting developers to try our services. We organize hackathons. So all these kinds of innovations and AI and cognitive, all kinds of fun stuff is happening in IBM. So I'm very happy about that. So if we start by talking about what is tone analyzer, this is in summary, it is a service that analyzes text. Can be a tweet, can be email, long document, blog, and whatnot, and it finds a set of tones and which can be useful to understand what this text is about. So tone analyzer helps people to detect and understand three types of communication tone. Social, example of social tones are like whether this text represent openness or whether this text represent agreeableness. Emotion tone, or whether this given text it represent it has anger, fear, disgust, joy, sadness, and some writing style or language style tone, whether this piece of text it is analytical, whether it represents some confident tone or tentative tone. Now this insight is useful because in a business communication or in a personal communication or different kind of communication scenarios, like in customer service or other one-to-one communication, if people can understand what tone they are communicating or what tone the other party is communicating, they can actually refine their tone, right? They could actually improve it. So this insight is very useful for impactful communication. This is a screenshot from our service. I will also show the live demo, which is in Bluemix. This is showing scorecard. We give emotion tone like 5 tone, as I was telling: anger, disgust, fear, joy, and sadness. So emotion tone is inferred from different type of emotion and feeling that people express in their language. So let's say if a customer is very unhappy about the service, they are talking to an agent, they might actually express a lot of anger and disgust. On the other hand, maybe if they're happy, they might express joy, for example. A writing style tone, people concerned with the style of the writing, and they might express analytical. Some people write in an analytical way, and some people write in a confident way, and or in a tentative way. So we also detect this kind of tone, show them in the scorecard. And the social tones are OCAEA. So openness, conscientiousness, extroversion, agreeableness, and emotional range. And the other name of this is neuroticism. They are actually coming from Big 5 personality model. I will talk about more details. But these represent people's like different social propensity or different social aspect of which is shown in their writing. In the areas of openness, conscientiousness, this means how organized this piece of writing is. Extroversion is like pretty much the name implies how extrovert, how much agreeable, and emotional range. So emotional range is like a high emotional range means low neuroticism. So people who show a lot of variations in their emotions. So that this piece of writing might, for example, show high emotional range, and vice versa. Tone analyzer, it can help answer a number of questions. How can I predict the way my written message will be interpreted? Let's say if it is a customer service scenario, again, like in many of these slides, I will talk about written, but you can imagine that it can be spoken, but we could also apply speech to text, and then we can also apply tone analyzers. So it does not need to be always written, but the service takes text. Does this piece of communication have the right tone to achieve my target outcome? So think about in a customer service scenario where the target outcome could be customer satisfaction. Now the agent should communicate in a tone that would eventually lead to customer satisfaction. Or if it is some matching scenario, for example, in an online dating or that kind of scenario, like now how two parties could actually come to a matched condition that their tone should also match. So these are some use cases, or it could be a business communication. Maybe one person is communicating with customer or different team members. So how their tone would actually impact the communication, that is very important. So what is the quality of communication happening between my customers and that I talked about? And for example, target audience is important. Like in a business scenario for a brand, when the marketing team, they actually write different messages for advertising or to influence customers. So how this will be perceived by the target audience, whether people will like it, whether people will follow the brand, or whether people might retweet it, right? They might spread it, or they might eventually buy the product from the brand. So a lot of things all depends on how the tone of the message of the brand being perceived by the audience. So the benefits of improved quality of communication, increased communication effectiveness, improved customer satisfaction. We will also talk about few studies we have done in that space, and reduced cost of poor communication, because poor communication can be very destructive. Going into a bit more details, how does it work? Tone analyzer takes text input in multiple formats and produces JSON. These are some architectural details. The input can be text, as I was saying, that the text can be from email, can be from like corporate announcement, could be from blog or other article, can be from social media like Twitter. Now we do a lot of pre-processing, and we have this API analysis platform, and we have a lot of linguistic algorithm going on in order to understand, to produce the score of emotion tone, social tone, and writing tone. And underneath this linguistic analysis, we also trained a whole bunch of machine learning model that is used to infer the score for this set of tones. And the output is in JSON format, and in terms of application, it could be useful in different visualizations. For example, we have a demo up in Lumix. It could be useful to integrate with other solutions like IBM's SPSS and other solutions. It could be integrated to a mobile app or different other applications. Some use case example, customer service I already talked about, how to satisfy the customer, corporate communication, run, for example, press release or executive speeches. These are corporate speech. Tone analyzer can be useful. Think this one like a spell checker. So when before the corporate speech or some press release is communicating to the public, tone analyzer can be applied, and based on the current tone, that the message can be improved before it can go to public. Marketing campaigns, email add-on, as I was saying, like think this like a grammar check or spell check. Before sending an email, we could apply tone analyzer, and that might actually show different tones that is produced from this email, and then the email can be sent. Persuasion automation, which is how we can influence people to buy more product, or how we can influence more people to like my brand. So a lot of things could be depend on how the message is perceived by the audience. So tone analyzer can be useful. We have seen a lot of industry which is being benefited from this tone analyzer, like customer care and insights, a whole bunch of use cases in customer care, marketing, health and wellness, in communicating to a patient. For example, how a doctor would communicate to a patient. So in doctor-patient communication, especially in mental illness scenario, it's useful. And hospitality, like for example in a virtual assistance, if we want to develop a dialogue agent or a cognitive agent that would actually communicate with human in different places, for example in a hotel or other concierge services, tone analyzer could be actually useful to have an effective communication. We could combine tone analyzer with other services. For example, in this chart, we are showing that a robot hotel concierge use case. A customer works on robotics. There is text to speech, speech to text. Both could actually work. For example, if a customer is talking, so we could actually translate to speech, and then after tone analysis, we could actually put the text back to speech. IBM Bluemix has a lot of other services like NL classifier, natural language classifier. We have conversation services. So with all these pieces, tone analyzer could be added to have a effective communication or a concierge service. So that it might be useful in a robot-human communication. These are some like customer stories that we have used tone analyzer in analyzing tweets in when Australian Open tournament was going. We do this kind of thing quite often when some big events happen, like US Open, Australian Open, and so on. We actually try to understand what people are talking about this event or a particular particular brand. Inventor is another company that optimizes agent effectiveness with tone analyzer. So they were actually applied tone analyzer, and based on the tone, they actually trained their agent so that they could actually make better communication with their customer. Now I will show you a demo how it is available in IBM Bluemix. Here, this service, as you can see, we have some sample use cases like customer service chat, email, and corporate announcement, and you can also put your own text. Let's say for this customer service chat, if you press analyze, so you can see that the output is in different level. These are document level tone. So basically, for the entire conversation, it takes the text, passes it through the tone analyzer. Tone analyzer computes output, and this is showing the scores. So for this one, anger score is pretty high. So for emotion tone, this is detected as anger because customer was actually expressing a lot of anger about the service. The text in terms of language style, tentative, and social tendency was extroversion. We also output, yes, question.
Does the tone analyzer differentiate between the dialogue between the agent and the customer? And is this the customer tone or is this the whole context?
For this particular example, this is from the whole thing. So tone analyzer is the way it works. Given text, it can output tone, right? So what we recommend that if you have such conversation, you want to differentiate between what is the customer's tone and what is agent's tone. You do that pre-processing, some kind of like tokenization or splitting, right? You actually separate the customer part, you separate the agent part, you call tone analyzer separately. Because tone analyzer for it just understands text. It does not have that domain knowledge. We also output the sentence level. So for this particular example, we are for each of the sentence applying tone analyzer. This is for anger tone. Here is another example where the email message. So one thing I like to mention here, as tone analyzer produces different scores. Let's say for this emotional score, we recommend that if a score is above 0.5, then we recommend that there is a dominant tone. So in this particular example, we are seeing that anger score is 0.91, so the dominant emotional tone is 0.91. However, this joy 0.02, 0.11, they can be ignored. So mostly this dominant emotion tone is 0.91 anger. So it's pretty high anger is represented in this text, and it shows analytical. We can actually take a look at this snippet of text. So you can see that like someone, maybe the manager or some executive, is sending the message to the team and talking about sales have been disappointing, and you know, we need to acknowledge and fix these things, and so on. So they're actually expressing a lot of anger, which tone analyzer is detecting. And as I was showing in the previous example, it can detect sentence level as well. And since this is a service, depending on your application, right? Whatever it is, like you can actually pre-process, click the text, and then invoke tone analyzer. So now going back to the slide, I'll tell you some details about how we infer each of these tones. So the first tone is emotion tone. In order to understand emotion tone, we will need to talk about how this emotion model is developed. So the problem setup, given a piece of short text ideally, even though we are applying on long text, but typically the emotion detection problem works well or better on short text. Detect the emotion conveyed in the text, where for this particular problem, we are focused on these 5 categories of emotion: disgust, fear, joy, anger, and sadness. And these emotion categories are actually taken from this wheel model, where there are many kinds of emotion. So we could actually add more emotion to our model based on availability of training data and based on customers' need. So according to this wheel model, there are 8 primary categories. For the current release of tone analyzer, we are not using all 8. We are focusing on 5 because these 5 we felt, based on feedback from our users, these 5 we felt more useful. But we might also add other tones like other emotions like surprise or trust. So the aim to develop emotion model is we want high accuracy, we want short response time, because this kind of service will be useful in a real world scenario. So response time needs to be fairly short. Scale, it needs to be scaled because transparency is ignored. Since these are machine learning model, we don't need to always explain how this score is being computed. If it was a rule-based thing, then we might always give you evidence that, okay, we got this word, so this score is like this and that. But in a machine learning model, a lot of things are actually coming from different weights that is computed during the training time. There are a lot of dependencies and so on. So it's not always transparent. So these are like, you know, the trade-off between machine learning and rule-based model. Assumptions, as of now, our approach is supervised. So we collect training examples, we train the model, and then we can test the prediction for that model. We have this limited number of labels, but we could add more, as I was talking, like frustration, confusion, and whatnot. Now, you might say that many emotion models exist. If we look at literature, there are a whole bunch of emotion models. There are like matrix factorization-based approach. There are SVM-based approach. Bunch of like state-of-the-art using state-of-the-art classifiers. People actually developed emotion model, and they talked about and published papers, for example. Also, IBM has this natural language classifier, NLC, and we could also take some training examples, use NLC, and train emotion model. So there are varieties of possibilities. Now, why not select the best performing, accurate and fast model? Complex models might work on very complex cases, but you know, they might have produced some embarrassing result on simple cases. That happen all the time. But simple model, they might only do simple things well, but they might not actually handle ambiguous cases. They might not handle complex cases. So what we are doing here is our approach is combining the best of the both worlds, both the simplistic approach as well as the complex approach. So what we do is we created an ensemble of classifiers, so where we put different kind of classifiers like matrix factorization-based classifiers, SVM-based classifiers, feature engineering-based classifiers. So we put a whole bunch of classifiers in an ensemble so that we can actually take advantage from best of all those different kind of things. And our approach is a stacked generalization type of ensemble, because there are different ways of creating ensemble. We are we choose this approach. Here is a diagram how our ensemble-based training works. Training data that is on the top, we get training data. For example, it could come from social media, could come from like blog, could come from news headlines. But this training data means given text, we know their emotion level. For example, this piece of text represents anger or joy or sadness. We take some amount of training data for example, because this is a multi-layer ensemble. For layer 0, we take some amount of training data, and we train different kind of model, like based on n-gram features, we extract n-gram features. We have non-negative matrix factorization-based classifiers, SVM-based classifiers, feature engineering-based, and also we create 1 versus rest and 1 versus 1. So what is 1 versus 1? Here, for example, we train a classifier that would differentiate between anger and disgust, or anger or joy. This is called 1 versus 1. 1 versus rest is, okay, this will say whether this is anger or everything else. So we create all those different possibilities, and which leads to about 34 classifiers in layer 0, and then we pass their classification to layer 1, and in layer 1 we create another few classifiers, and at the end we do some group model selection. So that's the pretty much architecture of our ensemble-based training approach.
And you're defining what each emotion relates to each particular piece of text?
Yeah, so this is part of our training process,
Okay.
where we have the annotated data.
Okay.
We know that this piece of text, this represents, let's say, anger. This piece of text, this represents joy. This piece of text, it represents sadness, and so on. Now, how we get this annotated data is another, like there are different approaches that I will talk about in the experimentation phase. Some of them are coming from asking mechanical Turkers to annotate. Some of them are coming from standard corpus like Semivel, EasyAir. Some of them are coming from soft labeling, where we look for tweet with hashtag, right? Tweet with hashtag joy or tweet with hashtag sadness, stuff like that. So that actually. Yes.
I'm sorry.
Sure.
Can you give an example of your binary classifiers?
Yeah. So one example of binary classifier is, let's say, one classifier that its task is given piece of text, it would tell that whether this represents joy, is a positive class, or anything else, any other emotions. This is 1 versus rest classifier. Now, 1 versus 1 classifier, example of that will be, given piece of text, this would classify between joy and anger. Either it is joy or it is anger. So we could train that kind of classifier as well. This is an example of 1 versus 1 classifier.
Oh, I see. So those are your standard, your binary classifiers are your standard classifications, and you're saying this is the stack to get to those.
Right.
Okay.
So also SVM-based classifiers, we created a bunch of like multi-level classifiers that, well, given piece of text, it would classify between joy, anger, so using state-of-the-art SVM. We actually tried all these different possibilities. We have a lot of feature engineering involved that I will talk about what features we focus. Now, each of these 1 versus rest or 1 versus 1 dictionary, and that become also our feature in the feature engineering classifier. Semi-coordinate is another dictionary that we used, and again, like matching with the dictionary, and that match score becomes feature in the classifier. Also, we have, I was talking about negation, scope detection. For example, I am not happy, and I am happy a little. So these are like some specific examples where people might have this kind of negative text. So we need to detect those occurrences and need to actually generate new tokens. So do some kind of score reversal. For example, if it is I am not happy, if we do not detect that, it might actually increase the score for happiness, but that's not the case. So we also do that kind of pre-processing.
Regarding earlier slide, don't you detect any emotion from punctuation? Is that why you remove it? This was an earlier slide.
Yeah.
Yeah.
So punctuations like commas and semicolons, we did not find them useful. Now, if you're talking about like emoticons, that we have incorporated, right? Taking emoticons into our feature space, but simple punctuations like semicolon, commas, or like dots, they are not useful as features. At least we did not find them useful in our experiment. But emoticons and emojis, they are useful.
But you
say you convert to lowercase, but if I say I am happy in all capital letters, it will express more joy, no?
It might. Yeah, so you're saying that if capital, that might emphasize more, right? Currently we are not taking that as another feature. You know, like feature engineering is an art, and all. Yeah. So explanation we take into account, but thinking about if you express disgust, and let's say if you capitalize it, right? Maybe it is more disgust. So this can be some additional feature we could try. But one thing we are as of our experiments we are finding that adding bits and pieces of feature does not have any significant impact on accuracy. After accuracy reaches a certain level, some addition of this kind of piece of feature is not giving any significant improvement. But we are continuously trying with different features. We have been also trying with what-to-back and neural network-based approach, because this is based on ensemble. Now we are experimenting with neural network and deep learning. So there are a whole bunch of possibilities. Talking about high-level features, right? Number of capital letters, capital words, expansion you're talking. So we have these expansion features, question marks, number of mention, hashtags. If it is a retweet, let's say it is coming from Twitter, number of special characters. So, and we are open to any kind of suggestion of feature engineering that we could try, because it's pretty much endless possibility to try and add more features. Talking about how we train or evaluate dataset with ground truth. There are SAM-eval and EASE-ER. They are academia dataset. If we read different papers on emotion modeling, in many papers, when people build an emotion model, they would compare their algorithm with using this benchmark data. So they are pretty much standard benchmark data that pretty much everyone who is working on emotion modeling compare their algorithm with this benchmark data. So we use this benchmark data. First one is from news headlines, and the second one is personal conversation. We have hand-labeled Twitter, and which are annotated by trackers, mechanical trackers, and soft level, which I was talking about, where we look for specific hashtags. Given a tweet, and at the end or somewhere in the tweet there is a hashtag joy or hashtag sad. These are soft level. So the data, they vary in level distributions. For example, in soft level data, we have found more happiness than joy, and so on. More happiness than anger or disgust. Like disgust or fear are not as easy to find in soft level Twitter data comparing to happiness or sadness. We also added some negation training examples, about 150, which are manually created using our domain knowledge and looking at lots of examples. And we do a mix of dataset selection where we have distribution from different kind of labels, different kind of emotion labels, so that we do not have specific bias towards a specific label. So we create a mix from all these kind of sources. Results on standard dataset. We compared our ensemble. That's on the right. That is our algorithm. But we compared with different baselines. Simple logistic regression based classifiers, non-negative matrix factorization based classifiers, SVM based classifiers, and for each of these datasets, Twitter hand label, SAM-eval, EASE-ER, mix 20, mix 48. So these are some mixed datasets we have created. So what we can see that, first of all, ensemble-based model, the accuracy is, and these are showing macro F1, is higher than other baseline approaches like NMF or SVM or so on. So the reason we are showing here macro F1, so that there is no bias towards majority level. And ensemble is better than other models. And SVM with all features better than regression, NMF is more data to perform. Now for our production, which is currently deployed as part of a tool service, one is part of tone analyzer. We deployed this emotion model. Also as part of IBM's Alchemy service. If you try Alchemy sentiment, Alchemy API, you will also, previously it was showing entity, sentiment, so and so, but now it also shows emotion score. So this output from this service also goes to Alchemy. So we have two phases where we actually use the output from this emotion model. So for production, we trained on mixed dataset, and we are continuously improving with additional data and retraining for our next releases. Is there any question from? No. Okay.
I have a question.
Sure.
If you wanted to look at the tone throughout a dialogue in a conversation,
Mhm.
but you had it in one large transcript, to be able to see a trend, would you want to break that up, let's say, into 4 sets and know that this is the progression?
Right.
And then run each one and then model those
Yeah.
together?
So this is basically, I can say that one of our future work is right now, this tone analyzer works on given text. It does not have any knowledge of the conversation. For example, this emotion model, the input is a given text. Now, this text can be one sentence, can be a paragraph, can be the whole conversation. But we do not have any option where you could indicate that this is a conversation, these are different terms, and this is between first person, between second person, or this is different entities. So we plan to develop or we plan to work on research where we could actually use this kind of meta-knowledge, or we could actually use this kind of knowledge about conversation, where we could use additional features from conversation and the model could output emotion, and that model could actually use that contextual knowledge of conversation to produce the emotion output. So I think that might be more effective. Talking about like social tone, as when I was introducing the service at the beginning, I mentioned that social tone is coming from our personality insight service. So when I talk about social tone, I will also show you a glimpse of that service. There are 5 dimensions of social tone: openness, conscientiousness, extroversion, agreeableness, neuroticism, or emotional range. These dimensions are coming from Big 5. So as I mentioned, they're coming from Personality Insight. Again, this service is developed from our team. So the problem is, given at least 4,000 words, they might come from Twitter, blog, email, and so on, so different kinds of social media, other forms of text, written by an individual. And the problem is to infer personality needs and values. So Personality Insight service, we output 52 traits, and we use 5 traits, the Big 5, as part of social tone in tone analyzer. We do linguistic analysis from text in order to infer these scores, and this is one screenshot of personality portrait of an individual that shows Big 5 values and needs, and each of the Big 5 has also their facets. Each of them have 6 facets, so there are 30 facets of Big 5, and output of the Personality Insight service can be useful in recommendation and various other scenarios. I will skip through this slide because we have integrated personality insights with different kinds of solutions, like in enterprise scenarios where we have enterprise data, we have social media data, we do some form of matching, and then we build personality model and use that model for recommendation. When talking about linguistic analysis, let's say we have this text, we do a lot of pre-processing, and currently we do matching with different word categories. Analyzes hundreds of millions of documents, so it's pretty fast. Currently, the service that we have in Bluemix that is using dictionary, which is Loop dictionary, but we are working on an extension where we might be using other form features. So dictionary is useful as just to extract one feature, but we use a whole bunch of other linguistic analysis to now, in order to train such personality model, we do survey. We collect ground truth of Big 5 values, facets, and needs, and we collect people's text. That would give us ground truth, the training data. Then we extract a lot of features. We train personality models, and later on we use those models for a given text. We can predict personality scores. Talking about personality insights accuracy, I'm showing accuracy in 5 dimension mean absolute error. So which is basically the distance between the predicted score and the ground truth score, which seems to be pretty decent. And correlation, again, like the correlation between predicted score and ground truth score Now, for this, even though you see that the correlations are not very high, but in this kind of psychological analysis where we are trying to predict trait of an individual, which is personality, which are self-reported, even correlation of 0.2 or these are actually pretty decent as we find from literature.
Question.
Sure.
The gram truth score, where is it coming from?
For personality insights? Yeah. So there are standard surveys, say for Big 5, there are standard surveys that have questions like 50-item IP survey. We ask people to fill up those surveys, and so when they fill up the survey, there are standard scoring method that computes score for each of the personality dimension. For example, extraversion score, openness score, emotional range score, and so on. So that gives us the ground truth personality score. We also collect the text from the same individual, and then we build model so that from the text we extract features. We have the ground truth. These are the predictor variables. We build machine learning model so that we could predict from a given text we extract features and we could predict the same scores. Just to give you more context, I also here have our personality insights service open. If you want to see the demo, quick demo here. Let's say we want to compute personality for this body of text. Right? I click analyze. So this is showing score of agreeableness 79 percentile. So one point to mention here that when personality insights compute these scores, it computes raw scores. It also computes percentile. So the way percentile score is computed is we have millions of individuals for which we know their raw personality scores, and we actually compare for a given score where it falls in that sampling population. So for this piece of text, personality of that individual computed is 79% agreeableness, so pretty high. Extraversion is 6%, openness, and need and value, these are other personality dimension. We also show some likelihood of different actions for this personality. This person is unlikely to buy healthy food or adapt to situations. So these are, you call it consumption preferences. So from this personality, we also compute these preferences we output here. So this is pretty, you might find this demo interesting. Feel free to try it. This is also like tone analyzer, also available in IBM Lumix. Going back and talking about for both tone analyzer and personality insight, we have our documentation where we talk about some of the scientific aspect, which might be also interesting to take a look. So the last dimension of tone analyzer is language tone. Three types of language tone that we compute: analytical, confident, and tentative. So the analytical is a person's reasoning and analytical attitude about different things. Confident is a person's degree of certainty, and tentative is tentativeness. That's pretty intuitive. The way we derive them is using linguistic analysis. We use a bunch of dictionaries, multiple dictionaries to derive the score for each of the language tone. So we have created those dictionaries from our domain knowledge by looking at a lot of example text that has this kind of tones. Each word is matched to the dictionary and has a weight which contributes to the tone score. And we normalize the raw score using a normalization corpus, and which is a large corpus of blogs, emails, and tweets, so that at the end we can output normalized score for each of these language dimensions. We also do some negation handling. So I was showing negation handling for emotion tone. For language tone, we also need to do negation handling because, for example, a text which is not confident, we need to detect that as tentative, for example. So we we have done some evaluation of language tone, even though it is pretty preliminary. So we asked people to interpret the tone scores from their writing and ask them how well they agree, disagree, and so on. And it looks like a significant majority of them tend to agree with the tone output that we are producing. And this evaluation we are currently expanding. We are doing much larger evaluation for language tone so that we can test more on the robustness of it. However, for each of these tones, we have done studies to show their validation in real-world scenarios, like how they are useful in affecting some real-world behaviors, which I will talk next. For example, whether they're useful in predicting customer satisfaction, whether they're useful in predicting whether people like a response. So this usefulness actually shows us that what the scores that we are computing have real-world effect.
Are you taking questions?
Sure.
So on that, you mentioned the 3 different corpuses that you use to set the raw score standards. So before you mentioned that the tags and the
Soft
tweets
levels, yeah, that's
gave
what
you different kinds of norms than the other information that you had, human identified emotions. So I'm wondering here if your norms are going to be different in blogs versus emails versus tweets.
You mean the normalized?
The distributions, yeah.
So there are some differences, but this is not like there is no significant difference in distribution. So when we combined text from blogs, emails, and tweets, we have looked at how the tone scores are distributed. So we have not found much significant difference. So that we could able to combine, and then we use a single corpus for normalization. So in this part, I will talk about how we apply tone analyzer in conversation, because a major use case of tone analyzer is in conversation scenarios, right? When a customer is probably talking with an agent, or conversation in a group forum, or other kind of scenarios. So our approach is we apply tone analyzer in multiple conversations. Study 1, question response in a QA forum. Study 2, Twitter conversation between customer and agent. That these 2 I will talk about. So in the first study, we took Autodesk QA forum data, and these are pretty public. We crawled some discussions from several forums, and we collected the most recent threads. A response can receive kudos from the forum participant, and we applied tone analyzer to get their tone scores, and then we investigated whether we can predict kudos received from tone score. So if we could predict kudos by tone score, that would actually show us that tone has effect on how a response is perceived by the audience. Here is the result from correlation analysis. We found a positive significant correlation between confident tone and kudos received, and the correlation score is 0.23 and is significant. So if a response show more high score on confidence, is more likely that this will receive kudos. Negative significant correlation between tentative and kudos, again this is pretty intuitive, that might follow from the previous conclusion. Positive significant correlation between openness tone and kudos. Positive significant between conscientiousness tone and kudos. So the response which are more organized, so that score high on conscientiousness dimension on big 5, they are also more likely to receive kudos. We later on, once we did this correlation analysis, we wanted to build predictive model whether we can predict kudos. So there are 2 plus kudo or no kudo from these responses. We did some balancing of the data set so that we have same number of kudos and same number of no kudos for these responses, and try different set of the classifiers and did tenfold cross variation. What we found, just by using tones as features, we could predict kudos with 66% accuracy, which is much higher than a random baseline, which would be 50%. Now you might imagine, we are not using any information content on the response, because whether a response will receive kudo, it does not only depend on tone, it also depends on whether the response is useful, whether the question asked, whether the response contains the answer, and so, right? So if we had those information, if we had those features also incorporated, like information and other anagrams and other things, we might be able to increase this prediction accuracy much beyond 66%. But what this shows that just by using tones, we could predict better than random. So this shows that tone has effect on how a real world conversation would receive positive outcome. That's some detailed classification result. Again, it's showing 66% accuracy. Study 2, where we applied tone analyzer in customer support conversation. So there are different companies, they have their customer support account in Twitter, and where customer can interact with those companies' Twitter handle. So we collected some of those conversations which are public in Twitter and applied tone analyzer on those conversations. So we applied on customer text. We did some pre-processing so that we could identify that these are the customer's turn, these are the agent's turn. We applied tone analyzer on each of them, and we investigated whether there is any correlation. Now, in order to do that investigation, both for correlation and the prediction, we also labeled the overall outcome. So we actually looked at the entire conversation and reached to a conclusion whether the customer was happy, satisfied about the service, or they are not satisfied, or neither. So we also did that kind of annotation. So 333 conversations were in total from these two public accounts. So we did data cleaning. As I was talking, that we separate conversation like customer tweets and agent tweets. We calculated the tone score for 13 tones. We also did some kind of thresholding, like categorize the raw tone scores into low, medium, and high. So this is anger. It is more likely that at the end they are not satisfied. Again, this is intuitive, but the positive thing is we are seeing what tone analyzer is detecting is actually useful, actually matches for the overall flow of the conversation or the outcome of the conversation. Negative significant correlation between disgust tone from customer's text and satisfaction. So if a customer expresses disgust, they are unlikely to be satisfied. Positive significant correlation between conscientiousness and satisfaction. Correlation result between agent and tone and satisfaction. So we found that if the agent expresses disgust, as our intuition follows that, it is very unlikely that customer will be happy. And we also discovered that when we compute this tone from agent's text. And similarly, if an agent text has neuroticism, high neuroticism, so high neuroticism and agent, they might express a lot of anxiety, they might express a lot of high emotional range, which is not necessarily good for the outcome of the conversation, which we also found that this leads to lower satisfaction. And then when we tried to build a predictive model, can we predict satisfaction versus not satisfaction using tones as features, both customer tone and agent tone? We found that on average we can do better than random, even though right now for this data set our accuracy is higher to predict satisfaction level, lower for predict not satisfaction level, and we understand that it is much harder to predict not satisfaction, and we are currently trying to expand the data set to have like more training examples to improve the accuracy of not satisfaction prediction. But on average we are 67%. At this point, I'm happy to answer questions.
So I was just thinking about many sites I go to, it asks me, would you be willing to take a survey after this? And that's sort of a self-validation for your satisfaction or not satisfaction during the course of the dialogue. I never thought of it in terms of that could actually be input into your training data set.
Yeah, so so that could be also useful. So when our goal here is we want to see whether tone has any effect on the conversation. In order to investigate that, someone needs to tell us whether customer is happy at the end of the conversation, right? Whether it was useful. Now, since we were analyzing public social media data, we had to annotate it, right? Because we did not, get this annotation from the company who is running the customer service, right? So we don't have the actual ground truth, right? So we have to annotate it. So by annotating by us or by asking mechanical targets to help us annotate, to look at each turn in the conversation and tell us whether the customer is satisfied. And at least what is positive about tone analysis is that we found that tone has real effect on overall outcome of the conversation, which is very important, especially in customer service domain, where you want to retain the customer, you want to make customer happy, and it is also useful to train the agent. If you find that this agent is expressing a lot of anger, for example, or this agent is leading towards a negative satisfaction conversation, so that particular agent might need training. So we are actually discovering all those different use cases and finding some evidence that these tones are useful. Now what we are currently brainstorming that whether tone applies to all kind of conversation. If a conversation is like that, some question asking, like information seeking, like let's say one person is asking some agent and asking, like, what is the capital of this country, and here is the answer, or what is this and here is the answer. So if it is only information seeking kind of conversation, then tone might not be that useful because you are not expressing any tone, you are not expressing any emotion in that kind of conversation. However, if it is problem reporting, like where people are like showing their emotions and concerns and all those kind of things, then tone might be more useful in such conversation.
Do you deal with ironic tones? If you don't deal with irony, you think that AI and machine learning will be able to do it, and if yes, how?
Yeah, that's a very good question. So dealing with humor, sarcasm, irony, yeah. So these are some of the future work that we plan to do. We have been looking at literature how people are doing that. First of all, it is very hard, as there are a lot of work on sarcasm detection. Many papers, but at the end of the day, if you look at the accuracy numbers and if you look at when it works or when it does not work, which is not very encouraging. So this is in our plan. We plan to use that. There are machine learning way to detect sarcasm or irony, but the hardness is you need some context to detect, right? If I just give you one piece of text and tell me if it is sarcastic, right? You might actually need more context, right? You might actually need what I was telling before, or you might actually need to know what kind of person I am, so you need more context. So just from one piece of text or from a given text, at least in our current scenario, the tone and emotion, right? We're not using any context information. We could probably do much better if we could incorporate or if we had access to such context. So that is one of the limitation of we don't have any knowledge of context, right? We don't, for example, we don't know what preference this person has, what is this person's background, and so, right? This other context could be helpful. Again, this is possibility, but this problem is hard. Sure.
I have two questions. The first is the tone analyzer better than a human's instinct or not, or how much better?
Well,
I could misinterpret someone's communication.
No, well, I think humans are very good. Humans are very good to understand emotion. So first of all, we have not directly compared this with human, but in some cases, right, our annotation is coming from human that we used as ground truth, and since it is not 100% accurate, so what we can tell that it is not as good as human, right? However, the goal is to apply them in an automated scenario, and then human can, as you said, human can often do not have enough time, right? If you have lots of text and conversation, you are actually not always noticing, right? So this kind of tone analyzer can be useful in a spell checker scenario that would actually give you signal that here is this different kind of tones. So, because if you are not paying attention, this can help. It can be useful to build automated agent or to make computer more smarter. But again, for example, sarcasm. If for a human, I think sarcasm is probably easier for a human to detect. But think about a computer to detect sarcasm. It's very hard.
Going back to your data
You had
cleaning.
another question?
Yeah, it's,
Another one? First one's good.
thank you. On that note, I think that it could be helpful in the future to improve a human's diagnosis of what someone's trying to communicate. So I think that's a cool future direction. But my other question was, I guess, related to ground truth. And what have you found is the highest possible level of accuracy you can achieve or confidence score you can achieve with the data sets you're currently using?
Right.
You know?
So here, what we have seen, using standard like SAN-URL, EZR, or that kind of data, we were able to be as good as like 80%, for example, right? But when we use large data set, for example, this Twitter, very noisy, we mix Twitter, blog, and this or that, then our accuracy is like on the level of like 66%. But think about, see, there's a problem of 5-class classification, right? So the baseline is, random baseline is 20%. But on academia data set, our accuracy is higher, like close to 80%. But on real world data set, where data can be really noisy, so it goes lower. And we need, what we are currently seeing, that we need more training, we need more high quality training examples. Perhaps we need to like label more training examples by more trackers, or by collecting more examples from different sources, by incorporating. Also, we need to incorporate more long document as training. That is another thing we are facing. Like our service, that it does not. What we are currently seeing, that the level of accuracy it gives you for, I'm talking about emotion service, for short text versus long text, we see some variation. So we are trying to improve our service by applying some technique for long text, or probably bringing more long text as training examples. So this is is a pretty ongoing process. Sure. Question.
So I have an intuition that the personality of the customer service person would be a very good predictor of how much kudos they would sort of gather. So the interesting question here, I realize you have a limited data set here. The interesting question to me would be the variation amongst that population, and also the variation that how strongly tone correlates to the outcome.
Yeah. So this is like a very good suggestion. So we are, I showed this two study as very preliminary study, that we started to see their effectiveness. We are currently expanding them with more data, looking at more possibilities. So correlating with personality of the participant with the outcome, or correlating tone with the outcome. Like this will be our ongoing effort. So
It might be useful to just sort of measure whether the tone information is noise compared to something else you're not measuring, which is embedded in the. Yeah, I appreciate that the tone is part. These things are convolved together.
Right.
It's the variations that I assume would be the interesting thing. There's another question. Did you consider pace as a tone feature?
Sorry, can you repeat?
Pace. When people answer quickly or not quickly, it may or may not indicate something about.
No, we don't.
Tone.
No, we have not considered that. We are only looking at text.
It seems like an easy feature to add.
Yes, it might. So first of all, like the data, a lot of data that we have access to, they do not have that meta information. We only have the text data. In some cases,
tweets have timestamps.
Yeah, tweets have timestamps.
Yeah, that's
yes. Tweets have timestamps. So whether if I reply fast or slow or so and so, whether it has any effect on any of these outcomes, it could be interesting to know. It's good suggestion. We did not think that might be useful for, but we'll try. Sure.
I used to work with a company that did analytics on property and casualty data, and it's usually just notes. Okay. And in the course of analyzing some of the data, you might find that road rage came up in the context of the claim, in a police report or in a conversation with an investor or something. And that can have implications about judging a person. And the thing came up as, well, would it make sense to send a notice to the policy system that at renewal time, this might be a higher risk because the person you're insuring may be showing attributes of road rage, let's say. So, you know, I don't want to be a buzzkill on this, but even in healthcare, like doing predictive percentages it's still ethically kind of confusing. Like, if you've got a 4% prediction rate for mortality versus 8%, are you 2 times more likely to die? And should you tell the customer that, or tell the patient that? And I've seen in the insurance industry clerks summarizing attributes that end up being in a person's log for a long time. So, are we kind of practicing medicine or psychology in here to a degree? And are some of these characteristics going to end up in the corpus of individuals that are going to be questioned? You know, I know IBM's got, and I'm not saying that's a challenge. I think what you're doing is great, and there's a lot of applications. But there's that side of it. You know what I'm saying?
Yeah. So you are saying that like the ethical concern, right? So whether some of the analysis we are doing, right? We are trying to understand people's tone. We are trying to understand like from text, right? What personality they perceive, right? Now, I think the ethical thing is more depends on the specific use, how you are using this information for. For example, if it is useful for like doing some product recommendation, for giving people better customer service, right? So there is hopefully no ethical concern. Now, there are some sensitive use cases where, as I can tell from IBM's point of view, we have a very proactive legal department, so we always so we always consult with our use cases, and we often like remove use cases where we get guidance from our legal that this is probably on the fence. So we do not work on those use cases. So we are pretty much concerned. For example, personality, right? Like if you apply personality in for let's say hiring or that kind of thing, right? So these are the couple of things that could be on the fence, right? So how you are using it, if it is some important decision that might impact someone's life or that, so we have to be careful how we are using this kind of information. These are very useful user attributes we want to learn, but our use case should be limited to the right context. And we know that, like in US, there are specific ethical guidelines. In Europe, especially in Germany, they have their very strict guidelines. So we have to be consistent with the country where we are applying it, specific culture and context, and that's why we always seek guidance from our legal team, and they are very good at.
So actually, it's kind of relevant to the question that there's an organization out of Chicago, I believe, Mattersight.
Mattersight, yeah, I have seen that. Yeah, they are
they've
customer service.
done stuff where they've analyzed the emotional tone of people's calls into customer service, and then they use that data to kind of create a profile emotionally of that customer. And then if they call in again and they recognize the incoming caller ID, they will route that call to an agent that's known to deal well with that personality type.
Right.
So it's actually being used commercially, and they're claiming that it cuts their call time in half. So that's a major, significant thing. Are you guys doing something similar to that?
We are aware of Mattersight, so when we do competitive analysis, we are aware of what they are doing. So yes, we are aware of that use cases. And this, for example, applying emotion and tone, we recommend different use cases. And customer service is one of the major use case that we are aiming for. That's why we want to build a smart, intelligent agent that would, converse with customer in a dialogue setting. Sure.
How about emojis? Are you going to do that?
Yeah, emoticons and emoji, these are our plan. Our plan to add those, also incorporate them to our service, and hopefully you will see them in one of the future releases. I hope so. We have been working on it.
When you're analyzing the tone, is it purely a mix of the big 5 dimensions and then any mix of those, or are you incorporating anything else as well? Because obviously, like, tone is way more complex than
social tone is coming from Big 5 score, as I was showing. Yeah. Emotion tone is coming from our emotion model. Language tone is by other linguistic analysis, and social tone I talked about. They are coming from Big 5 dimension. It's ocean. And they are coming from our personality insight service. That's why I also introduced that service briefly. These are just 5 social tones. They're coming from Big 5. But these Big 5 are computed as by our personality insight service. Yes?
Is the
presentation available because there were some reference material that you showed. Is it available online?
Well, online we do not have this presentation available, but online we have for each of our services like tone analyzer, we have documentation, and we talk about some aspect of science, probably not at that level of details, but we also have a bunch of references for each of these sections.
Yes, my question is, can a copy of this be shared with the Meetup?
Some of the content will be available when we update our documentation of tone analyzer. But whether this slide can be shared, I think.
It's up to you. You know,
Yeah.
I got it, but you know, if you say that it can be shared, I will share it.
So let me, let me do a quick check on the content if I want to. But I hope most of it can be shared. There is not much confidential thing here, but yeah. Let me do a quick check, and I will, if it is shared, then how we can share it.
Oh,
You can just
yeah.
Okay.
Yeah, normally,
Slide share? Okay.
yeah, or normally they send a quick email to me and then I
Okay,
can
that's
share
fine.
because
Yeah,
on the Meetup site,
Yeah.
you know, we have, a minimum set of that you can put up there as the file limit. So I tried it twice and I said, you know what, send me a quick email, I will send it back to you.
So let me take a look at the content one more time, and I will send you an slide deck.
Jalal, Alice, one more question.
Sure.
I think you had it.
I'm more interested in your n-gram feature. So there were logics to deal with, for example, like some kind of intentional typo, like cool to cool, like to reduce the O's, right? Do you do autocorrect before you analyze the text?
Well, we do not do autocorrect, but we at least maintain a corpus where we can detect that, for typos and that kind of thing. Currently we are not doing autocorrect. We could have maintained a corpus to do autocorrect, but here we do some simple like lemmatization, or for example, KOL is still recognized as cool, or CO.
I mean, would autocorrecting be a good feature?
It could be. Yeah, it could be, right? Because in Twitter and in different scenarios, right, people have unintentional typo, right? So we could
I think with the complexity of your analyzing algorithms, one typo can actually change your outcome, right?
It can to some extent, but as our algorithm is actually computing many features, also through many classifiers, so maybe a small thing is probably not affecting that much, but we could perhaps do some exploration where we can try with this kind of typo, this input, and see whether how much it affects the outcome. And if we see large variation, we might add such feature. Any other question or?
Okay, there is still a demo, okay?
Sure.
So Jalal, thank
Okay.
you so much.
Thank you.
So hi, I'm Jeancarl. I'm a technical evangelist for the Bluemix platform. So Watson and Bluemix work together. Bluemix is a platform you develop applications on using Watson and other third-party services that we have in the catalog. So I love my job. I get to build demos using the Bluemix platform and various Watson services like Tone Analyzer. And so I was tasked earlier this year to build a tone analyzer demo to analyze the tweets around a conference that we were planning. And so basically taking the social tones from the tone analyzer service, I did a basic little scoring system and then graphing them per minute and then overall for the conference. And so this way you can see by minute how your audience is tweeting or communicating about your conference. So you can see, go down the page, the legend of different colors that these represent. So these are the big 5 personality traits are from the social category of Tone Analyzer. And so this wasn't just enough to have a website out there analyzing tweets. They wanted some hardware. So we made this little wearable with the help of a designer. So those data geeks in the audience will say, hey, that's fashionable service. And then I have a little JavaScript function that goes through the results, finding the tone that is scored highest, and then passing it off to a database into IoT platform. So we can enable so I've enabled this toggle, and we're going to toggle that one. And so you can see the tweets are coming in. So if you actually search tweet IBM right now, your tweets will show up. And for those that are English, we can wait another second. So you can see you got the tweet, and then we have the highest scoring tone. So I aggregate all these together, I remit it, and then send it off to the IoT platform, which is our Internet of Things, where these pins, so that one's listening for the tweets. This one I'll share in a minute on what this one does. So these are aggregated and sent off to the IoT platform, where I have a particle photon listening to a message, and I have 5 different colors that you can send. It's just a string of 24 characters. Each character in the message corresponds to one of these LED lights and changes the colors. So if I toggle this one, in a minute we'll see the message that gets sent to the pin. So what's the value besides being a data geek and wearing this fashionable LED pen? Well, you can see the tone behind conference tweets and understand maybe when you're presenting, you can glance down and see if your audience is agreeable. Or you can see if the audience is agreeable.
I'd rather put it in the back so that you can see it at all times.
There you go. So you can see it's going to be all pink, and it should change shortly.
It did over.
It already did? Okay. And I guess there's other colors. That's actually upside down, rookie mistake. So that's kind of the analyzing Twitter. So we went to another conference, and let's make this actually interactive. How about one of you submit a message and see how your tone is? So I need a volunteer to pull out their cell phone and text a message. Looks like this guy is willing to fork over his phone number and other personal info. Just right? All right, so text a message to 410. Number 4, and then my tone. And that's 698663. So I will switch over to so while he's tweeting or texting me a message, I will share with you the 2 blog posts I wrote about how you can make your very own LED pen. So it just changed.
Yep.
There we go. And let's see. Red is extroverted, blue is emotional range, and you're agreeable. Is that right? What was your message that you tweeted?
Hello.
Hello.
Hello. Yes.
Minimal texting. All right.
Yes.
So, if you want to take turns in texting, you're welcome to. Every time someone texts a message, it's going to wipe out.
Kind of confess I'm not active because I message you, I'm so happy, that's why maybe
It is
So we got to share the pin. Just saying. So there's two parts to this, the Twitter tone analyzer. There's first one to create the application and get the website with the chart. And then I show you how to connect simple hardware like this. You can choose other pieces of hardware. It's just a message with the 24 LED pins, or you can modify that to represent whatever hardware you want to display the tone on.
Do you have a software simulator for the hardware for us lazy people?
Well, you can probably do that in Node-RED. Very simple. So, let's see. So, how does Twilio or text messaging work? Well, I changed the Twitter node to being a callback from Twilio. So we use Twilio in IBM Bluemix catalog. And so I have a phone number that you text to, and then Twilio will call my web endpoint, and then it will pass right through to the tone analyzer and analyze that message. Same thing, sending it off to the tone analyzer, or the IoT platform. So 2 pieces of hardware you need: a particle photon, and a neopixel ring, and a little soldering skill. Don't worry, even a beginner can solder the pins together. And then connect that to the IoT platform. So I mentioned earlier, Bluemix is a platform that you can develop your application on. We have Watson services, and then so you can go to bluemix.net, sign up for free. So under boilerplates is the Node-RED app, starter application, and you can create your own Node-RED application, drag and drop these nodes, create the tone analyzer, which is under Watson. As you mentioned earlier, personality insights is also another service in Watson that you can analyze the personality traits behind longer messages. That requires a bit longer than a sentence or one word hello. And then finally, when I started in September, I competed in the TechCrunch hackathon. And here is another example of analyzing email messages with the tone analyzer. So I have emails every morning, and we all have full inboxes, right? So on the way to work, I just want to read the more agreeable or happy emails, right? When I get to work, I'll deal with all the disasters. We never have disasters. So this hack basically reads the emails from Microsoft Outlook, sends them through Tone Analyzer, and then we get the scorings, which I kind of massage into my own algorithm, hackathon style, and then rank them into the more agreeable traits.
Kind of like that.
And then I have this little audio playlist that it will cycle through each of these emails and play them. So that's kind of a quick and dirty 24-hour hack that I did with Tone Analyzer. And I didn't really have to worry about all the algorithms behind Watson. I was able to just pass in the email content and get the scores back and focus on what was important was the application and making sure that it was accurate. Any questions?
A question that's a little off, but it's related to speech to text.
Okay.
Covering that too. So there's a demo of the Watson speech to text, and it shows some beautiful punctuation in the output. And when we've actually used the speech to text module with stuff, everything comes up pretty good, but punctuation does not happen. So what I've heard from my business partner is that he had talked to somebody who said that there was some extra code that somebody wrote that does the punctuation. You know anything about that? Heard of that?
I'm afraid I don't know about the punctuation part. Do you know?
No, I'm
Or speech text?
We can look into
We can
that.
follow up with you if you
Okay,
want to
good.
leave your contact. No other questions?
No? Okay.
Thank you.
Hey, thank you so much. I got actually one more question. So, this is a political season. And, I totally forgot to look up, whether there are cognitive applications that are specifically for the political arena. Do you guys know about some of them?
So there's actually, we can,
There is
Yeah?
a demo. We have a demo that does the
Oh, about-
selection and looking at who's the article that's out there.
Oh, the articles. Yeah, I saw that. Yeah, I saw that. Okay.
so election insights.
Yeah.
I try to stay away from politics.
No, but it's interesting. You get those questions. You get those questions. Yeah.
And so you can see the positive, neutral, negative. I believe that's the sentiment around these
And then
candidates.
you can click it. You get the message, or how do you? Oh, okay, got it. Okay.
Very dangerous clicking.
Oh
on
yeah.
content.
Oh yeah. Oh yeah. Oh yeah. Okay.
And
Pretty
so
cool.
all these examples have a fork me on GitHub, and you can deploy very quickly into Bluemix and get up and running in Bluemix, start modifying it through the online editor or even via command line. You download the code, modify it, and push it back up to Bluemix, and it's a matter of minutes, less. And you can have it scale across the world using our infrastructure.
So another question that I seem to remember a demo that I think maybe you did, Jeancarl, of something that would identify unusual or unique terms in a body of text. Is there a tool? Because we were trying to figure out if there's something that does that within the Watson or Alchemy.
So unusual.
Well, like infrequent terms, like maybe, if you had Inuit or something in there, it would use that as identify that as a tag that could be used for that purpose.
So Alchemy is another Watson service that we acquired last year. Let's see. So if you go to Alchemy language, and we'll analyze this piece of content. And so Alchemy language is a pretty powerful API that you don't have to train. And on the left side, you get all these different types of content analyzed. So keywords, entities, concepts, sentiment around the specific words that are being mentioned, and then overall sentiment.
So you could generate tags, for instance, automatically using that.
Right. And that it's just, so you have the left column, the relevancy, and each term has sentiment. Which brings up another topic. We do hack nights on August 22nd at Runway Incubator in San Francisco. We're focusing on weather this month, and so you can learn all about the weather and company data API. It was just revamped with a bunch of new features like alerts and in-depth forecasts. So if you're interested in that, you're welcome to join. The link is ibm.biz/digitalsv. so you can learn about weather. We do this every month, so different topics on Watson and other Bluemix services.
Shall I cross-promote it
Yeah.
if you
I
want?
can
Okay,
put a
I'll do
message
it.
up there.
Yeah. Okay, got it. So September 13th, there is another meetup, is Data Smart, from information to insights. Actually, it's a repeat that we did, I think, more than 6 months ago. So I don't know if you signed up and you already been to the first one. It is a repeat. Maybe you want to double check it again. But Niyati is our data scientist on the Watson team, and was a pretty good meetup. Very technical, and she could answer a lot of questions. So, but it's a repeat. Okay. Okay, guys, that's it. Thank you so much, and I hope to see you next month. Jalal, thank you so much.